Okay, in the last class we were discussed about the electric current, then electric potential difference. Electric current is defined as the rate of flow of charge or the amount of charge flowing through any cross section of a conductor in a given time. It is defined as the current. Then in order to generate an electric current, the necessary and sufficient condition is electric potential difference. Then potential difference is defined as the work done to move a unit charge from one point to another, or it is the work done to move a unit charge between any 2 points is defined as the potential difference between that 2 points. Then we defined the SI unit of electric current as ampere and the SI unit of potential difference as volt. Next we have to consider when we can say the electric current is 1 ampere, or how we can define 1 ampere. The 1 ampere current means if 1 coulomb of charge is flowing from one point to another point in 1 second, then the current is defined as 1 ampere. That means if 1 coulomb of charge is flowing in 1 second, then the current is 1 ampere. Unit charge is flowing through any cross section of a conductor in a unit time, that is 1 ampere. That is a possible question. Define the SI unit of electric current. Then define the SI unit of electric current means the SI unit of electric current is ampere. Then we have to define 1 ampere. That means if 1 coulomb of charge is flowing through any cross section of a conductor in 1 second, then the current is 1 ampere. We already learned the equation for electric current I equal to Q by T, the charge divided by time. In order to obtain the current as 1 ampere, the charge Q should be 1 and the time that also should be 1 second. So 1 ampere equal to 1 coulomb divided by 1 second. That means if 1 coulomb of charge is flowing through any cross section of a conductor in 1 second, then the current is 1 ampere. In the same way, how we can define the potential difference? The SI unit of potential difference is defined as 1 volt. Now, how we can define is 1 volt, or when we can say the potential difference between any 2 points is 1 volt. The 1 volt potential difference is defined as it is the work done to move a unit charge between 2 points. If a unit amount of work is required to move a unit amount of charge between any 2 points, then the potential difference is 1 volt. We have the equation for that potential difference V equal to work done divided by charge. It means W by Q is the generalized equation we defined. Then in order to obtain the potential difference as 1 volt, the work done should be unit and the charge should be unit. So the total work done W, then the unit of work is joule. So 1 joule divided by 1 coulomb gives 1 volt potential difference. That means we can define 1 volt potential difference as if 1 joule of work is required to move 1 coulomb of charge between any 2 points, then the potential difference between that 2 points is 1 volt. If 1 joule of work is required to move 1 coulomb of charge between any 2 points, then the potential difference between that 2 points is 1 volt. Okay. Now next we have to define another term, that is the electric circuit. Electric circuit means that is a closed and continuous path of electric current. An electric circuit means it is a closed and continuous path of electric current, that is defined as the electric circuit. It should be a closed one and it should be a continuous one. Such a path of electric current flow is defined as the electric circuit. Then the schematic representation of such an electric circuit is defined as circuit diagram. The schematic representation or the drawing of a particular schematic drawing of a particular electric circuit is defined as a circuit diagram. Then in order to simplify the complexity of drawing such an electric circuit, we have to use electric symbols. That means instead of representing the actual shape or actual dimensions of certain components in an electric circuit, we have to use certain notations or representations instead of certain devices or components. Such kind of a representations is known as an electric symbols. In a circuit, different types of electric components are required. Then, in order to represent such components in a simple way of representation, we are using certain electric symbols. So, just we have to familiarize certain symbols commonly we are using in a simple electric circuits. Surely, we require connecting wires in order to construct an electric circuit. So, the connecting wires are represented with this kind of a solid lines. While forming a particular circuits, different types of connections are required. Then the joint between these connecting wires are represented in this way. In certain situations, the wires are overlapping over another one without connecting between that one. That is a wire crossing without joint. That is represented in this way. Then another one we can normally using in this particular electric circuit, cell. Cell is represented with these kind of two parallel lines. One is a longer one and other one is a shorter one. The longer one represents the positive terminal of that cell and the shorter one represents the negative terminal of that cell. The next one is the battery. Battery means combination of two or more cells is known as a battery. The combination of two or more cells is defined as a battery. That is represented in this way. Then the next component is the key. That means instead of switch we are using the term key. The switches we can use in two modes. One is the on condition and other one is the off condition. Instead of that one, here we are using this open key and closed key notations. Open key means that is switch off condition and that is represented by this way. Then a closed key means that is representing the switch on condition, that is represented in this particular manner. The next one is a resistor. Resistor means that is a component which is used to create a resistive ability or a opposing ability for the flow of current, that is represented in this way. Then types of resistors are the variable resistor, that is represented in this way, and another type of variable resistor is rheostat. The representation of rheostat in this particular manner, that is a type of variable resistor. Okay. And the next one is bulb. The bulb is notated in this particular manner. In any circuit, instead of a bulb, we can represent this kind of a notation, just representing the filament of that bulb. And another two notations are this. One is the voltmeter. Voltmeter means that is a device used to measure the potential difference between any 2 points in a circuit. That device is known as a voltmeter and the representation is in this way. And the voltmeter should be connected in parallel to that particular points. Between any 2 points we have to measure the potential difference, and in order to measure that potential difference, that voltmeter should be connected parallel to that particular region. That is a voltmeter. The next one is an ammeter. That is also a measuring device. Ammeter is a device used to measure the electric current in a circuit. Ammeter is a device used to measure the electric current in a circuit. Then, in order to measure the electric current, the ammeter should be connected in series with that particular circuit. Through which part of a circuit we require to measure the current, the ammeter should be connected in series with that particular region. And okay, we defined the electric circuit. That means it should be a closed and a continuous path of an electric current. Then in any electric circuit, in order to generate an electric current, we require a voltage source. Commonly using voltage sources are this cell and battery. Okay. Then after creating a potential difference, there should be a current flow. Then what will be the direction of current flow? The direction of current flow is little confusing one. Conventionally, we are taking the direction of electric current as from positive terminal of the cell to the negative terminal. It's starting from the positive terminal and ends in the negative terminal of the cell. In every circuit, there should be a voltage source or a cell. Then the direction of current conventionally we are marking from positive terminal to negative terminal with an arrowhead. In order to represent the direction of electric current, or for the completion of an electric circuit, we have to mark the direction of current, and the direction of current should be always from positive terminal of the cell to the negative terminal. That is the conventional direction of electric current. And the confusing fact is that we already learned that electric current means it is a flow of charge. Which type of charge? The negatively charged electrons are flowing. Generate an electric current, the flowing charges are considered as electrons, the negatively charged electrons. And in an voltage source, at the positive terminal, that there should be an electron deficient region, or it is a positively charged one. Positively charged means negative charged electrons are deficient in that region, and the negative terminal of that cell is sufficient with the electrons. That means more number of electrons are there. Comparing with the protons, more number of electrons will be there. That's why it is a negatively charged region becomes. So in order to generate an electric current, these negative charges should be flow from one terminal to another terminal. So the charges should flow from negative terminal to positive terminal. Actually, the electrons are flowing opposite to the conventional direction of electric current. Whenever we ask which is the direction of electric current, we have to consider it as from positive terminal to negative terminal. Conventionally, we are marking the direction of electric current from positive terminal of a cell to the negative terminal. But when we are considering the charge flowing direction, then that should be from negative terminal to positive terminal, because electrons are the negatively charged particles and the electrons are flowing from negative terminal to positive terminal.